So there's a number of couple of issues, so I went and double checked the directory on Ranger, and I got rid of the link there, the symbolic link, and it should just be pointing to a directory now. Can someone try out the thing on Ranger and let me know if it is now accessible?
Yes, we are on Ranger, and you set the tower makefile to a directory, and that has only owner read permission on /work/00283 tg45546 tau-2.19.1/x8664 /lib/makefile.tower.papi mpi.pdt-pgi. that only you have the read permission, whoever is the owner of tg45546, and nobody else can read. So when we run the build _/tau.sh, it complains that that file is there, but it's not readable.
All right, let me see. Okay. Okay, I think all those make files should now be, looks like there was just a couple that were not, and that was probably just the ones you needed, right? So give that a shot and see if that now works.
Yeah, I think now it is, the make is progressing at least.
Okay, great. Yeah, sorry about those things.
Yeah, the build _unrest.sh, that worked okay, but that should give some output file. So, and that grep command gave one line of it.
Okay. Yeah, so I think that should now be fixed. And the other one was the param directory, I think. Is that now accessible also? When you run unres, then it should on Ranger, then you'll, if that's not accessible, it will fail. But it should. I checked it. I got rid of the link there, so it should all be good. If someone could just confirm that they're able to run unres on Ranger.
I'm still compiling unres _ tower.
All right. So yeah, maybe just let us know if you're unable to do that. I think it should all be sorted out. What I wanted to do is, so you've got the example build scripts and things there that kind of show you how you go about it with the makefile, but I'd like to sort of take it with a very simple example from beginning to at least to the analysis stage, to kind of tie it together, and then play around with some of the analysis files and show you some of the things I was talking about in the during the presentation, but which are difficult to describe. It's much easier to show how that works. So I'm gonna do this on Ranger, but the basic process should be very similar across the different machines. Also, I did add a link to some of those example tau analysis files, the PPK files, on the Google Groups page. So on the performance profiling optimization page. So check that out, and if you want to play around with some of those. I'm going to be doing that here in just a minute, though, also. So if you want to do that while I look at it. So,
those PPK files we can just copy into our laptop and run paraprof on it, right?
That's right, yeah. And if you click on them, I think that paraprof will probably ask you if you want to open it, or so you can open it directly just by clicking on them, or you can download them. It's probably best to download them, and then if you double click on them, then it should just open up paraprof.
Okay, on my Linux laptop, I just set paraprof and that PPK file, and then it opened the
yeah, if
GUI.
you're working on Linux, yeah, then that would be the way to do that.
Okay.
So I grabbed the MD example from exercise 3 of the MD exercises. So I don't know what he named it there. I named it md.cpp. So it's the C example there. If we were going to start with a very simple file, then assuming that you have the right compiler set up. So on Ranger, I want to run with this version of Mvapich, and Intel, probably the regular version of Mvapich would work also. I was running into some problems with Mvapich on another code, and I found this worked. Anyway, so I've got my compiler set, and so it would just be the regular. For a C++ code, then you'd be running MPI-CC right on the command line, and so we can compile the. So we can just, so if we compiled this code like this on the command line at TAC, so it compiles fine. Then to compile it with tau, then we just want to make sure that the proper tau is in our path. And so you can do that, like I said, loading the modules. I was working with ones, before they had the latest tau set up on Ranger, I was working with this, and so I just kept it. So I would just set the environment variables. This is what the module command does. It will just set these environment variables. So export the path to the binary bin directory and also to the lib directory. So you just want to make sure that's in your path. Okay. Now, is there anyone? Is there anyone who cannot read the text here? Okay. So you want to set this up.
Hey, a bigger, bolder font would be nice if you could.
It would be nice. Okay. Let me see if I can do that. So I've just. Let's see if we can. Gotta. How are we doing now? Is that better?
Much better.
Okay. So get this off of here. That's that. Okay, so now I just exported this path, just set the path and LD library path variable so it knows where the proper tau is. So now, if I ran, so I previously, I ran this command to compile this simple MD code, right? So then if I want to do the same thing with tau, now that I've got it in my path, then I would just do, it's a C++ code, so I do tau underscore cxx.sh and the name of the file and call it md underscore tau. Oh, and I need to set the make file, right? So all right, so set the path, and then you pick a tau make file. So that's why I do this in a script, because there's a number of different options there. Actually, it's probably easiest to just, since these are very long, well, we can do this. So I'm going to set this tau make file environment variable. And so I pick, so here's all the different, if I tab complete that, then it shows me all the different tau make files available. I'm running Intel, so ICPC, I want one configured ICPC rather than PGI, but if you are doing PGI compilers, you want to make sure that you've got one configured with PGI. And then here's all the different options we talked about. If you want to try it on a hybrid code, then you need one configured with OpenMP and Opari. So Opari is, I think it's sort of the equivalent of PDT for instrumenting. It does some automatic instrumentation of OpenMP code. So, if you want to use the automatic instrumentation, then you need Opari as well as OpenMP. And then if it was hybrid code, you'd want also MPI in there. And if you want to look at the PAPI counters, then that. But in general, you want to use sort of just the minimal, whatever you need for the job at hand. In this case, I'll just go with the Intel compiler with PAPI and MPI. And so I'll set the tau make file and variable to that. And then you can also tau. So then you also want to set this tau options variable. And so one of the things that we can do is we can tell it to keep the instrumented source files. And this is also where you would set up a selective instrumentation file, where you'd point it to a selective instrumentation file, for example. So we're going to, for right now, we're going to just tell it to keep the instrumented files. And now we can run this command from the command line. So that will chew on that for a second.
Just one comment while it's compiling. Most of us are given default account with C shell, so we may have to use setenv instead of the export you are using, right? Yeah.
Exactly. Yeah, it would just be, if you're in C shell, it'd be setenv and then the name and then a space instead of an equals sign.
And what is that command en you are using to cat the file or edit the file?
Oh, that's windowless Emacs. It's an alias.
Oh.
Right.
Oh, okay.
That's my own alias. Yeah.